Hi everyone, so in this video we're going to review GCD and division lemma, but in a fun way. So those are both things that you will need to know. And how they combine, or at least one of the ways that they combine, is called the Euclidean algorithm. So this, need to know. Both of them. But this one, not so much. Okay, so you won't be tested on the Euclidean algorithm, but you do need to know things about the GCD and the division lemma. So let's go over a quick overview. So GCD is of two natural number, well, sorry, they don't have to be two integers, two non-zero integers. Okay, GCD is two non-zero integers, and it ends up being, so D, where D divides N and D divides M, and if K divides N and K divides M, then K is less than D. Okay? So it's the greatest common divisor. So it's a common divisor that they both have. So D divides N and D divides M. But also, if something else divides both of them, then that something else is going to be less than our D. Right, so that kind of makes sense. It's the greatest, so it's the biggest, and then it's a common divisor between the two. Okay, and then division lemma. So let N and M be integers, be non-zero integers. Then there exists unique integers, say K and R, such that N equals Km plus R, but remember we have one last thing, where R could be 0, but it's definitely less than absolute value of M. Okay, so kind of the way that you think about it is we're trying to figure out, well, if we did divide N by M, how many times would it divide into it? And then if it doesn't divide into it perfectly, what's the remainder? So that's kind of the way to think about it. Okay, because remember, if R is 0, then we have N equals Km, and that is one of the definitions of M divides N, since K is an integer. Okay? All right, so that was like a fast overview. So now you might be interested, how in the heck do these two relate? They seem fairly different. I mean, we're talking about dividing stuff, so maybe that's what it's about. But actually, it's something kind of exciting. So let's say we pick two, well, maybe I should pick two numbers, actually. I didn't think about this. So I'll pick two numbers, and we'll try to figure out what the GCD of it is. Okay, so I took this straight out of your textbook that you have on D2L, how to think like a mathematician. So as you can see, it's on page 201. So the Euclidean algorithm, if you just grab two integers, there exists, so non-zero, there exists integers q1 through qk and a descending sequence of positive integers. So where the last one, this rk plus 1, is going to be 0. So that's going to be important later in the definition. Keep that in mind. So we start off with our division lemma. Okay, so we apply division lemma. Here, let's zoom in. Let's zoom in. Okay, so we apply division lemma. But who on? Well, on x and y. Okay? And then we do it again. Division, so I'm going to call it DL. But on who this time? Well, actually, on y and r1. And then we do it again. Division lemma on, well, r1 and r2. So where do we keep pulling these from? So we have y here, and then y moves over there. Well, actually, let's trace R1. How about that? So R1 starts as the remainder, and then it's the multiple, and then it's the thing that it's the thing we're dividing out of, or quotes and air quotes. Okay, so everything keeps shifting over one. So same with R2, etc., etc., etc. Okay, so your remainder for one line is going to be the multiple for the next line, which is going to be on the other side of the equal sign on the next line. So you're probably thinking, well, what in the hubbubalub are you talking about, Danica? Well, here's the punchline. So it looks like this might be a bunch of busy work. But actually, once we get all the way down to here and we finally get our remainder to be 0, and so remember that was our rk plus 1 to be 0, then we know that rk divides rk minus 1. Okay. So rk divides rk minus 1. All right, why in the heck is that helpful, and what does that even have to do with x and y? Well, let's repost. Oop. Give me a second. Okay, my rabbit's snoring. I doubt you can hear it, but it's the cutest thing ever. Okay. Anyway, so now we've gone down. So what in the heck does this have to do with this, which would be an incredible result? Because often it's very difficult to find the GCD of two integers. Okay, so here we go. What we're going to do now is we're going to start working backwards. Okay, so we're going to start at the bottom, and now we know, whoops. Okay, so now we know that rk divides rk minus 1. So why is that helpful? Well, that means that rk minus 1 equals, let's say, what's the letter we haven't used? Oh, we haven't used m. M1, I don't know. Yeah, we start with ones. Okay. M1 times rk. Okay. And that's helpful because we can go back and plug, ooh, oh my gosh, that was ugly. We go back and plug that in over here, and we end up getting that rk minus 2 equals qk minus 1 plus, times m plus 1 times rk. So how in the heck did I get that? Well, I plugged this in here. Well, sorry, this in here. So I got m1 times qk minus 1 times rk. And then I combined that whole thing with this. So I ended up getting this crazy constant. But all I care about is this is an integer. So that means that rk divides rk minus 2. And we can keep going and keep going and keep going. And then all of a sudden, we're up here. So let's start here. So we know, we figure out from here that rk is dividing r1. But we already knew from here that rk divided r2. Maybe let's just call it m. It's okay. How about that? So this one gives that r2 equals m2 times rk. Okay, and this one gives that r1 equals m1 times rk. So now we plug both of these things back up here, and we have that y equals q2 times m1 rk plus Oh, k minus 1, sorry, is what I meant for this m. Okay. Plus m2 times rk, which is q2m1 plus m2 times rk. So rk divides y. Wow, how insane is this? Okay, so let's call that, so let's say that y equals my, so creative, right, times rk. Okay, and now we could plug that into here, and so we get that x equals q1 times my rk plus m1 rk, which once again, q1 my plus m1 times rk. So rk divides x. Wow, holy guacamole. Whew, okay. A little lightheaded, right? Man, lots of craziness happening. But that's how this even makes sense to even attempt to define rk as our GCD. Okay, so now we know that rk is a common divisor, but remember, that's not enough. We want it to be the greatest common divisor. Well, that comes in, and so I'm not going to prove it unless there's popular demand. You can email me if you really want me to prove it, but I'd rather go through an example. But kind of what it comes down to with why this is going to be the greatest is because of how the division lemma is set up. So because we know that these remainders have to be less than the multiple, okay? Or at least the absolute value of the multiple. So it's not like R1 is going to be 2y or something like that. And then that would really screw up a lot of our stuff. Okay, so we find the smallest things, smallest things, smallest things. Okay. Okay, but now I'd really like to, I'd really like us to get into an example. But I hope this at least somewhat makes sense. So once again, you're not going to be tested on Euclidean algorithm in this class. You will be tested on GCD and division lemma on their own, or maybe even together, who's to say? But not in this way, not with Euclidean algorithm. But I just think that this is kind of exciting, kind of fun. I know the first time I watched a professor throw all this out, I just was, I don't know, I couldn't believe it. I had such a hard time believing it. But it does work, so I'd really like to show you all an example. Okay, so I'm going to go a little bit back on my word, because your textbook really has a good summary of the proof. So you can look at it, you can think about it if you would like, look at your textbook and things, but I'd rather move on to an example. Okay, so if I was just trying to solve this with a calculator and no idea of the Euclidean algorithm, this would take me a very long time. So let's see. How do we normally do this? Well, you want to think about, so let's say that we did 3563 equals some multiple k times 14,441 plus some remainder, and we were trying to figure out what k and r is. Well, k is certainly going to be 0, right? So this doesn't work out at all. Okay, so k is going to be 0 and r is just going to be 3,563. So our next step would be 14441 equals, and then our r is this times, I don't know, maybe L this time, plus T. Okay, so save yourself the struggle and just pick the smaller of the two and have that be the multiple. Okay? All right. So I can imagine lots of people would have questions about that. Like, does it matter which one you do? And technically it doesn't, as long as you do it right. but it can save yourself a lot of time if you do it like this. Okay, so I'm not going to do this long division in my head. Let's just pull up our handy dandy calculator. And let's see. So 14441 divided by 3563. Oh yeah, here, I'm going to show you a trick. So this 4, oh, I forgot I can't write on a calculator. So this 4 is our K. Okay, so K is 4. So we have 4 times this. Okay, and then if we minus off the whole number, and then we times it by 3563 again, we get what our R is, 189. And if you would like to check me on that, we can. So let's do it. 4 times 3563 equals that plus 189. Boom, roasted. Okay, cool. So now we're gonna move this over and this over. Okay, so now we have 3563, and we want to know how many times does 180 multiply into that? All right, 3563 divided by 189. Okay, so 18 times, and then if we minus the 18, okay, then we times it by 189, that gives us our remainder, 161. All right, rotate. So we have 189 equals something times 161. Well, this one I can kind of eyeball. This is only going to go into it one time. Okay, and then their difference is, let's see, so 8, and then, oh yeah, 28, yeah, okay. It's been a long day already, and it's, what, noon? Okay, cool. So we still don't have remainder 0, remember that's what we're looking for. So we're going to rotate them over again. So we have 161 equals something times 28 plus junk, and I'm not going to try to do that in my head. Oops. 28, 5, and then 3/4 of 28. 21. Oh yeah, I should have known that. 7th. Okay. Cool, cool, cool. Still don't have that nice 0. So we have 28 equals, once again, it's just going to be 1 times 21. Those are the easiest ones. Those are nice. Plus 7. Ooh, awesome. Okay. All right. Now we're cooking. Now we're boiling. So it's going to be 3 times 7 plus 0. Pew, 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 pew. So this is our greatest common divisor. How crazy is that? I don't even remember what numbers we had. Like, there's no way I would have guessed that, okay? Even if you knew that 7 went into both of them, how do you know that's the greatest? You know what I'm saying? Like, you would have to really think about that and, like, really come up with the proof. Or you can use the handy-dandy Euclidean algorithm. All right, so I hope that was fun. Hope you all have a great week.